Okay, so we are in your books doing the Enquiry Lab on page 587. And I've recorded this lecture a lot. It's a lot more nerve-wracking when you have your face on it, but bear with me, whatever this take is, I'm keeping it. I want to show you some shapes, which is why I have the video on me as well. But back to the lecture, we are in that book and we are working on how are some three-dimensional figures related to circles. So Kenji is training his dog to run through an agility course. One of the activities is a tunnel, which is an open tube through which the dog runs. So our activity is a three-dimensional figure with faces that are polygons are called polyhedrons. So a polyhedron is like a pyramid because the face of it right here is a polygon. It's a triangle. Another polyhedron is going to be this shape because the face of it is a trapezoid. And then we have this cool little figure, and it is a polyhedron because the face of it is a triangle. But then we have some figures that are not polyhedrons, and their face is not a polygon. So an example of this would be like a cylinder, because the face of it is not a shape, like on its own. The bases are. The bases have circles, which is the shape and a polygon, but the face of it is not. Another example is going to be our cone, because even though we have one base of a circle, its face is not a shape on its own. It's kind of a curved triangle, which isn't a polygon. And another example is a sphere, which is a ball. It doesn't have a polygon for a face. So those are all examples of non-polyhedrons. So we're going to talk about each of those shapes and how we see them in the real world and some real world examples. One real world example of a cylinder I always think about is a can. So when you have like a can of beans, a can of corn, those are cylinders. So one example we have is a can. Another example of a cylinder, if you ever buy like oatmeal that are just the oats, that container would be a cylinder. And then another example I kind of thought about would be like your tumblers that you have. Mine's not exactly a cylinder because it does kind of have a curved bottom, but if you have a tumbler that's just a straight side, that would be also a cylinder. A cone, your obvious one, you have your ice cream cone. A orange traffic cone. And then like a funnel. Not the food, but like if you're trying to funnel like oil into your car or something like that, that's what I'm talking about. A sphere, obviously you have your ball, whether it's a basketball, volleyball, baseball, soccer ball, any type of ball. You also have like a bubble. And another one would be like the earth. The earth is round. So those are all real world examples that you see. So just as a rectangular prism and a pyramid have bases, so when we talk about that, this is our pyramid, and the bases are the things at the bottom. The base of a pyramid is obviously, this one's a square because it has equal sides, but it's a rectangle, usually. The cylinder and a cone have bases as well. So the bottom of my cylinder, so this is my cylinder, and then this is the base of it. It has a circle as a base. And then here's my cone. The bottom of it has a circle as a base as well. So these answers are circles. What we're going to talk about next is if we actually, so I'm going to erase this. It's interesting that shapes can occur when you find the cross sections of a figure that is not a polyhedron. So describe the shape of the following figure resulting from a horizontal cross section at each of the following. So what it means is if I took this cylinder and I cut it in half, straight across, horizontal, I would have, what shape, if I pulled it apart and cut it across, would I have as the bottom? And you would have a circle. So that green part right there would be a circle. And then if I had a cone, if I cut that horizontal right there, I would have a circle as well. It's kind of interesting on your cone. So if I cut up at the top, my circles are going to be smaller. And then if I cut further down, my circles would get bigger because the object gets bigger down at the bottom. And then we talk about a sphere. So if I had a sphere and I cut it straight across right there, I would actually get a hemisphere, and it would make a circle as well. It's interesting, though, that if you cut shapes at different angles, they would actually make different shapes on the diagonal. So what I mean by that is when we took our cylinder and we cut it straight across, it made a circle. However, if I was to cut it at a diagonal, like right there in the pink, I'm going to make this bigger. Like this one is cut diagonal, that pink part, it actually makes a different shape. So that would actually be an oval if I cut a cylinder at an angle instead of just straight across. So your job is to do the next page, 588, numbers 1 through 6, and you're just going to tell me if you cut those shapes at that angle that it shows you in the green. If you cut those shapes where it shows you at that green, what shape would it make on that green where you cut that figure? So 1 through 6, take a picture of it and submit it to Google Classroom.